Hello learners, in this video we're still considering forces. So we'd like to consider the main topic is still forces. So under forces we want to consider flow is at rest, flow is at rest. So what happens to an object when it is completely submerged in a liquid? Suppose an object is completely submerged in a liquid, right? You can have a liquid like this, a container. This container is filled with a liquid. Suppose it's submerged an object like this. This is our liquid, right? So when this object is submerged in a liquid, it will experience an upward resultant force. So there's the weight of the object, of course some other viscous drag force as well. Viscous drag force is there, but we want to consider this upthrust. So it's not okay, there's the weight on the object, of course there's the viscous drag force. So this object will experience an upthrust due to the liquid. So if an object is completely submerged in a liquid, it experiences an upward resultant force due to the liquid, which is called the upthrust. This is in accordance with Archimedes' principle. So we want to state Archimedes' principle. What does Archimedes' principle state? I want to state Archimedes' principle. So Archimedes it states that if an object is completely submerged in a liquid, it experiences an upward resultant force, which is equal to the weight of the liquid displaced. This is what Archimedes' principle states. It says that if an object is completely submerged in a liquid, it experiences an upward resultant force, which is equal to the weight of the liquid displaced. The upward resultant force is called the upthrust on the object. The upward resultant force is referred to as the So if an object is completely submerged in a liquid, it experiences an upward resultant force which is equal to the weight of the liquid displaced. The upward resultant force is referred to as the upthrust. So upthrust is measured in newtons. Upthrust is measured in newtons. Upthrust is measured in newtons. So, want to consider formula for upthrust. So, we'll refer to this is our object. Right? So, this is the weight of the object. So, it will experience an upthrust. So, upthrust upthrust is equal to weight of liquid displaced. So weight of liquid displaced is equal to volume of object. Because if an object is completely submerged, it displaces an equal volume of liquid. If an object is completely submerged in a liquid, it displaces an equal. So volume of object is equal to volume of liquid displaced. So volume of object times density of liquid. Rho is for density of liquid times acceleration of freeform shear. That is the formula for upthrust. So weight of liquid displaced is equal to volume of object, density of liquid times shear, acceleration of freeform. So volume of object is equal to volume of liquid displaced. So I want to move on to the explanation of the origin of upthrust. Explanation of the explanation of the origin of upthrust. Upthrust is as a result of pressure differences. Upthrust is as a result of pressure differences which arise between the lower part and the upper part of an object when it is completely submerged upthrust is as a result of pressure differences which arise between the lower part and the upper part of an object when it is completely submerged in a liquid. Let me further explain then. So this is the pressure difference between the lower part and the upper part of an object when it is called submerged in everything. So here, upthrust is a result of pressure differences between the lower part and upper part of an object when it is completely submerged. After that, there is a lot of pressure difference between the lower part and the lower part and the upper part of an object when it is completely submerged in a liquid. Pressure on the lower part is greater than pressure on the upper part. Pressure on the lower part or pressure on the lower part is greater than pressure on the upper part, because liquid pressure increases with depth, because liquid pressure increases with depth. So as depth increases, liquid pressure increases, right? So pressure on the lower part is greater than pressure on the upper part for liquid pressure. As a result, there will be a resultant upward pressure on the liquid, on the object. As a result, there will be a resultant upward pressure on the object. This is basically the explanation of the origin of upthrust. Upthrust is a result of pressure differences between the lower part and the upper part of an object when it is completely submerged in a liquid. Pressure on the lower part is greater than pressure on the upper part because liquid pressure increases with depth. As a result, there will be a resultant upward pressure on the object. So I want to derive the formula for upthrust. Derivation of the formula for upthrust. Upthrust is equal to volume of object times density of liquid times acceleration of free fall g. So I want to refer to a container. So in this container, a cube, right? So literally, the pressures are balanced. So this is the liquid surface. So the depth there is H1. Okay. I simply say that the depth there is H1. And the depth, so the depth from the surface of the liquid to the lower part of the object. So this is our object. So depth there is H2. From there to there is H1. From there to there is H2. So H1 minus H2 is going to be equal to H. H being the height of the object, right? So both the upper and the lower part and upper part have area A. Upper and lower part have area A. Can you see? So we can elaborate more. Upper and lower part have area A. This up, lower and upper part. So let's proceed to see how we arrive at this formula. Right. So by saying this is our object, literally the pressures are balanced. So this is H2, then we say this is H1, right? Then we say this is area A, then this upper part is area A. Then this depth of liquid is H. Then we say H1 minus H2 is equal to H, right? Pressure on the lower part. Pressure on lower part is equal to H1 density of liquid G. Force on lower part would be equal to this pressure times area. So we can call pressure on lower part A. Which pressure on lower part we can call it MPN, right? So pressure on lower part, yeah, right? So force on lower part, pressure on lower part, which is this is going to be H1 density of liquid GA, right? This pressure on lower part. So now pressure on lower part force on lower part is H1 rho G A. Then one pressure on upper part. Pressure on upper part. So pressure on upper part would be H2, right? Force on upper part. Force on upper part would be, which is pressure on upper part times area, which will be H2 rho G A, right? Can you see? So H2 rho G is pressure on upper part, H2. Force on upper part would be pressure on upper part times area. Pressure on upper part is H2 rho G A, right? So force on upper part would be H2 rho G A, right? So force on lower part is greater than force on upper part. So net force, net upward force will be equal to force on lower part minus force on upper part. Can you see? Which is going to be H1 rho G A minus H2 rho G A. Right? So you can factor out there and here. And therefore, rho G A H1 minus H2, right? So this is the force on upper part, lower part is greater than force on upper part. So force on lower part minus force on is net upward force, H1 rho G A minus H2 rho G A. So factor out rho G A, H1 minus H2, right? So net force will be rho G A H1 minus H2, right? H1 minus H2 is equal to H, right? This will finally become net force will be rho G A H, right? Since H1 minus H2 is equal to H, we should take this was our object. This was H2. This was H1. So H1 minus H2 is the height of object H. So H1 minus H2 is H. So it will be the net force will be rho G A times H. So A times H is equal to volume of object. So this will be rho G times volume of object. Right? So finally, this will be volume of object rho here. Therefore, upthrust is equal to volume of object, density of object, density of liquid G. Right? So we have justify the formula for upthrust. We have justified the formula for upthrust by making reference to this diagram. This is our liquid surface. This is the liquid, so height of object is h. So finally, we've justified the formula for upthrust. Now, we are going to consider the calculation example on upthrust. We should consider the calculation example on upthrust. Relation example on a sphere of density, a sphere of density 8,6 grams per cubic centimeter is submerged in oil of density 12 grams per cubic centimeter. So it is a metal sphere, right? The diameter of the sphere, is 0.5 millimeters. Calculate upthrust on the metal sphere. Calculate upthrust on the metal. So this is the question there. So it will take note of the density of the oil, diameter of the sphere, right? So let us calculate upthrust. So upthrust is equal to volume of sphere times density of oil times G. So volume of sphere is 4/3 times pi times diameter of sphere cubed times density of oil. Density of oil is 12,000 kilograms per centimeter and 9,81. So if you substitute this very well there, if you calculate very well, you should get an answer of 7,705 times 10 to the power minus 6 newtons. Okay, so in the next video,